All right, so let's take a look at one of these type of problems. What you'll notice on these problems is they want us to write a quadratic function in standard form with the following zeros. Okay, so these are two separate problems. We'll deal with kind of the easy version and the slightly more complicated version. So over here, they are basically giving us the answer to a quadratic that they've just solved. They said that the answer is that x equals 5 and x equals -4. In this situation, think back to when we solve these problems and really work backwards. When we get a solution of x equals 5, that comes from a factor of x minus 5. And when we get a solution of -4, that comes from a factor of x plus 4. When we solve this, that would be fully factored, and we'd be able to solve each. Now, rather than going, here's our factored form to a solution, we're going in the other direction. So now we want to unfactor. Okay, we're going to unfactor by distributing. Some of us might think about this as foiling, but we need to multiply all the components in the first parentheses times all the components in the second. And I will get x squared plus 4x minus 5x minus 20. And I'm going to simplify my middle two terms. I'm going to get x squared minus x minus 20. I know this is in standard form because my exponents go in descending order from 2 to 1 to 0. Sometimes we'll see solutions that come as fractions. So the start of this will look the same. I know that my solutions here were x equals 2 and 2/3. So what I'm going to do is set this up the same way I just did, with factors of x minus 2 and x minus 2/3. Now, one thing about standard form is that we can never include fraction coefficients, okay? I need to resolve the issue that I have here. I need to get rid of my fraction, okay? So what I'm going to do is I'm going to really clear this fraction by multiplying, all right? I want to multiply this expression here, this factored form, by the denominator that I see there, okay? So when I multiply this by 3, I'm going to multiply that 3 in to both of these terms. So I'll still have my x minus 2 here, but now instead of x minus 2/3, I'll get 3x minus 2. Which again, just as a quick aside here, 3x minus 2, if that equals 0, that means that 3x equals 2 and x equals 2/3, which is where we started. My last step here, I'm going to distribute in. I'm going to get 3x squared minus 2x minus 6x plus 4. And finally, I'm going to simplify the middle two terms, 3x squared, combine them to get -8x plus 4. This is our fully simplified form. Again, my exponents go from greatest to least, and all my coefficients are whole numbers or integers. Just as a quick side note, what allows us to do this? Well, the original problem, there are actually an infinite number of quadratics that have the solutions 2 and 2/3. If you notice the original problem, it said write a quadratic function in standard form. We could have multiplied either of these factors by any number. If I really wanted to, I could multiply this by 10, and I'd get the same result. I'd have the same solutions, but we want to use simpler functions whenever we can. So the steps you want to follow, you want to put your answers into factored form. You want to multiply any fractions out in order to get only integers, and you want to fully simplify your quadratic. And we're done.